Here we are on the top side of the battery. So the bottom side of the battery, if you remember, had the nickel strips covering sort of these areas, and so on the opposite side of the battery they're shifted by one. Alright, so in this case the battery starts to become active, which means let's say from here to down this direction we have a 12S configuration, which is around 48 volts. Right now it measures at like 46 volts, something like that. We're still doing the same technique of soldering each of the balance leads to the nickel strip first before it's then tack welded onto the tops of the batteries. If you notice, at the ends we haven't connected these yet, right? So like when we connect these, we'll end up with 96 volts, and in total 192 approximately. Now to connect from here to here, we could put one long nickel strip, 150 microns, let's say 0.15 millimeters thick. But it wouldn't carry the current nearly as well. In this case, the current travels from this cell to this cell through here and here and here, so we have like kind of 4 strips, if you will, connecting, which gives us good load carrying ability, and it doesn't heat as much. Over here, at this point right here, we'd actually be carrying 4 times the current, which is not good. So we're making a high current bus bar for that. Now, when we input the current, we'll input the current here, 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 and here, so with 4 separate wires, possibly 2 thicker ones. They'll travel down here, so we need 1, 2, 3, and we'll come out here at the negative. So we need 3 bars to connect that. So over here, we're building those things. What we've got is a nickel strip, 8 sections long, and then we're soldering a piece of Romex, sort of house wiring, right? So you buy this at Home Depot. Cut it open, take the ground. If you want the line in neutral, then you have to take the jackets off of it like this. For that, I use a wire stripper like this one, and then I grab onto the end of it with some other pliers like this, just using the grippy end, and then strip it right off. Now to get these soldered on here, it's a bit tricky because they keep wanting to move around a lot, and so I have this tool right here. Kind of stays shut when you let go of it, and so I put that onto it kind of this way, like that, and then that allows me to solder it, and I kind of tack weld a few of them, and then I go down the line soldering in between, because when you solder one of them, it kind of liquefies the ones next to it, and this tool helps to hold it in place. So you kind of work back and forth until you've got it. Now, the idea for these things is that they go on here. Now, at the point where the battery is live, if I was to put this on in like certain configurations, it would, short circuit, so we don't want to do that. Essentially this will end up getting tack welded here, just like that. Now the spot welder that I'm using is a 709A Sunco, and it seems to only be able to barely weld up to 150 micron thick nickel. So you might think, oh well, let's use some nickel strips and just bulk it up with like 3 more, so that makes a total of 4, and that should carry the current. So I tried that, and what happened is that soldering nickel onto nickel apparently absorbs too much heat, and the tack welds just come right apart, which would be terrible. And so we decided to go for this soldering approach.